Okay, so 10.2 is systems of linear equations with several variables. So we're going to be working with 3 variables and 3 different equations today. And the first thing that we're going to do is called back substitution. So this is a triangular system. I'm actually going to talk more about that in example 2. A triangular system is when you have an x, y, and z in the first equation, just a y and a z in the second, and a z in the third. And we call this back substitution because you can start with the last equation and then plug it into the second one to find y. Plug those 2 variables into the third equation to find x. So if we start off with z equals 3, and we know that y plus 4z equals 8, then we can go ahead and solve for y. So y plus 4 times 3, which is our z value, equals 8. 4 times 3 is 12, so if I subtract that from both sides, I'm going to get y equals negative 4. And now that I know z and y, I can substitute those into my first equation to find x. So I have x minus 4 times negative 5 minus 3 equals 22. So a negative times a negative is going to be a positive. 20 minus 3 is 17. And then you're going to subtract. So your x value is 5. So just like we did for our bell work, we are going to write it as a coordinate point. And that coordinate point is going to be 5, negative 4, 3. Okay, how did you guys do with that without me? Good? Okay, so now what we're going to do is example 2. So example 2, you have to find the complete solution of the linear system, or you're going to show that it's inconsistent. Okay, if it's inconsistent, what that means is, well, actually, do you guys know what it means? Yeah, it's going to have no solution. Okay, so there will be no solution. And we'll talk about the different cases when it does have no solution. So example 2, find the complete solution of the linear system, or show that it's inconsistent. Do you guys know what happens when you get no solution?
You have like the same equation, or like I think total limit gives a different answer.
You are going to have an equation. So what would happen is all the variables would cancel out, and you'd be left with an equation like 0 equals 5. That's not true. So if it's not true, there'd be no solution. It's inconsistent. Sometimes you'll get a true statement. If it is true, do you guys know what it is? Infinitely many. Yep. And we're actually going to write that down a little bit later. Logan, can you put that away? So for part A, okay, here is your system. Okay, so this is given to you. Now, there's a few different ways that you can do this. AP Stats people, do you guys know how to solve this? Like when you're typing?
No.
For real? You don't?
I can draw Instagram. I can draw Instagram. So we're using a calculator or
No, you're not. We're doing it by hand right now. Hey, so like I said, today we're going to set the groundwork for when we do start to work with matrices. Now, one way that you can solve this system is by putting it in the triangular format that we had in the first example. So that's what we're going to do with part A. Your goal is to get a triangular system. Okay, and what is a triangular system? Well, that's going to be when you have x, y, and z in the first equation, and then that can be equal to any number. Okay, and then in the second equation, you want y and z, and again, that can equal any number. And then the third equation, you just want z, and that can equal any number. All the coefficients that for this one were 1, but your coefficients don't have to be 1. The only thing that makes it triangular is the form of the variables. So x, y, and z, and then y and z, and then z. And the reason why that's nice is because if you have that format, what can you use to solve? Yeah, good, back substitution. Okay, so then you can use back substitution to solve. So that's what we're going to do with part A. So the first thing that you want to do is eliminate x from the second equation. Okay, so we're going to eliminate x from the second equation. Okay, now if you eliminate x from your second equation, what you want to do is pick any two equations and then use elimination. So I just use equation 1 and equation 2. Okay? If you like to be told what to do versus finding out what to do by yourself, you could always follow this. If you like finding new ways, then you could pick any two equations that you want. And I'll actually go over that second way in part B. Okay, so I have equation 1 and equation 2, and then I want to eliminate the x. So, Celia, what could I do to one of these equations in order to eliminate my x? Okay, yeah, so let's multiply the first one by negative 1. So if I multiply the first equation by negative 1, I'd have negative x plus 2y minus 3z equals negative 1. And this one is going to stay the same, so x plus 2y minus z equals 13. And then just like what we did for the bell work, we're going to add straight down. So my x's cancel. I have 4y minus 4z equals 12. Now, if you can reduce it, then you really should. This one you can reduce, so we are going to do that. Because what goes into everything? 4. So we're going to do 4y minus 4z equals 12. And really reducing it just makes it simpler for you in the long run. Okay, so now here's my equation. This is going to be my new second equation. Okay, so now let's write our system. Okay, and then I'll show you why. Okay, so your first equation is going to stay the same. So that's still going to be x minus 2y plus 3z equals 1. This is going to be our new second equation. So why is this our new second equation? I did use it. What else? Yeah, the second equation, you want to have a y and a z. So technically, you could plug that into any position that you wanted. We want it in the second row because we want it to have the y and the z. Do you guys think you can tell me what we're going to do next? What our next goal is for step 2? Okay, Okay, so we have to clean up equation 3. So we do have to eliminate the x and the y. First, we're just going to eliminate x. Okay, so our second step is going to be to eliminate x from equation 3. Now to do that, you can always take equation 1 and 3 to do that. You just can't use equation 1 and 2 again. Okay, so I use equation 1 and 3. If you wanted, you could use equation 2 and 3. Okay, so again, I'm using 1 and 3. If you want to do 2 and 3, you could. You just can't use the same 2 you used in the previous step. Okay, so Adam, if I want to cancel out the x's, what do I have to do? Good, so that's what I'm going to do. Multiply the top equation by negative 2. So I'll have negative 2x plus 4y minus 6z equals negative 2. Just be careful when you are doing the multiplication, because sometimes something small can mess you up. And then we're going to add straight down. So the x's cancel out. Now I have 8y minus 13z equals negative 1. Can I simplify anything here? No, I can't divide by anything. So then this is going to be my new equation 3. So let's just, with this being my new equation 3, I'm just going to show you what my system is. You don't have to write your new system every time you do this. I'm just doing it to show you while we're doing the steps that we're doing. Okay, so now my new equation 3 is 8y minus 13z equals negative 1. So our step 3 is going to be to eliminate y from equation 3. Because like Jonathan said earlier, we have to eliminate the x and the y, so we just split it up. We do the x first and then the y second. Now, having it in this format, I think it's clear to see what your two equations you have to use in order to eliminate the y. Okay, so Abby, what do you think? What two formulas are we going to use? Yeah, yep, because that's now our system. So what I have up there, that's our system now. Yep, you have to use the second one and which one? Nope. Yeah, but can you think about why? Okay, so yeah, you're trying to eliminate your y, and 2 and 3 are the only ones that have what? And aren't 2 and 3 the only ones with two variables in them? Okay, so if you were to try to use these two, then what would you still have left when you added down? Like if you try to use these two to eliminate, or these two to eliminate, then when you try to eliminate the y, that like you could multiply this by 4, right? But then you'd have 4x, and that would come down. But you don't want that. So you have to use these two because you only have the two variables. Okay, so basically you're solving those two equations to find what your z value is. So you're going to use equation, well, 2 and equation 3. I'm just going to put new equation 2 and new equation 3. Okay, and then Emily, what do we need to multiply by? Great. Okay, so then we're going to multiply by negative 8. So negative 8y plus 8z equals negative 24. And the bottom one's going to stay the same. Okay, so then Logan, what does our z value end up being? 5. Okay, so now let's look at our system. And this is going to be part of our solution. Actually, why don't you guys try to write your new system? And then you can check it with mine. Okay, so your new system, and then look and see if you have that in triangular form. and then once you have that system, can you find your x and your y? So will you do that for me? Can you do that without me? Do you feel comfortable doing that without me? No, not so much. Yeah.
I don't know which equation was just used for that.
You'll use the first one. So okay, so your new system is x minus 2y plus 3z equals 1. And then this is going to be now, this is your new equation 3. So we had to do 2 new equation 3's. This is your final one, because with equation 3, how many variables did we have to eliminate? 2. So the first time we eliminated the x, then we eliminated the y. So this is going to be your new system.
So you keep one equation.
Yes. Yep. So if this is our new system, well, we already know that z equals 5, and now we can use back substitution. So y minus 5 would equal 3, which means y would be what? 8. And then for the first equation, it would be x minus 2 times 8 plus 3 times 5 equals 1. And so this is negative 16 and positive 15. So x minus 1 equals 1. So x would equal 2. So then your final answer would be 2, 8, 5. All right, and then let's look at B. Did one of you have your hands up?
Do we need to solve this answer just because we're going to matrices?
Right.
Okay.
Okay, so for today's, you don't have to solve it like a triangular system. Okay, you could also solve it by eliminating variables. Okay, so you would pick a variable to eliminate, and for the second one, I am going to go through that with you. How you can do it without a triangular system. The benefits to the triangular system are, one, if you like being told what to do, you can follow a certain format, and you can always do that, and then some people like it. Some people like being told what to do. Another good reason why the triangular system works is because then you have back substitution that you could use. And then the third good thing is when we start to do matrices, there's going to be a certain form that we're going to put it in. And if you have practice finding the triangular system, it's going to be very similar to that. But you don't have to solve it in that fashion. If you want to solve it in a new fashion, what you could do is eliminate x from 2 equations. And you can pick what 2 equations you want to do this for. Say it again. I really do want you to see both ways and try both ways. But you could try it the other way as well.
It's our use of instead of basically just solve it. I didn't know how to do that. Yeah.
Okay.
But just like so like what I could do is just multiply these by like have a common denominator in x.
And then yeah.
And make sure they cancel out.
Yeah. Okay, so for B, you're going to eliminate x from 2 equations. So the 2 equations I chose were just 1 and 2 because I wanted to give you a systematic way to find it. So if you take equation 1 and 2, you have x plus 7y minus 7z equals 3, and then 3x plus 14y minus 16z equals 17. So essentially, what we're going to do is we're going to create two equations with two variables, because like we did for bell work, if we have two variables, then we can solve those with elimination. So what we're going to do is I like to cancel out the x. And if you're canceling out the x for this, Nathaniel, what do we want to do?
We want to solve
So what am I going to multiply by?
at 3.
Close. Negative 3, yeah. Okay, so we're going to multiply by negative 3. So then we'd have negative 3x minus 21y plus 21z equals negative 9. And then this would be our new equation. So negative 7y plus 5z equals 8. Okay, and this is going to be our new first equation. And then step 2 is going to be to eliminate x from two different equations. So you can't use 1 and 2 again. You have to use any two different ones. So I do 1 and 3. Okay, so see if you can do that with equation 1 and 3. Okay, yeah, okay.
And then what'd you say that you wanted us to do for this?
Eliminate x from two different ones. Okay, so equation 1 is x plus 7y minus 7z equals 3. Equation 3 is 2x plus 7y minus 9z equals 10. Okay, and then Colin, what should we do here to eliminate your x? Okay, good. Well, 2 or negative 2. Okay. So negative 2x minus 14y plus 14z equals negative 6. This one's going to stay the same. Okay, so then I'm going to get negative 7y plus 5z equals 4. This is your new second equation. And then your last step is just to solve the new system of equations. Okay, so you're going to solve the new system of equations for y and z, and then once you know y and z, what are you going to do to find x? Plug it back in, right? So plug in values to find x. Okay, so here's my new system. My new system is just negative 7y plus 5z equals 8, and negative 7y plus 5z equals 4. Okay, so when I go to multiply this, because what am I going to multiply by? I'm going to multiply by negative 1. Zoom out. Okay, so when you multiply this, you're going to see something special happens. Is that what you're going to ask me about, Logan?
What?
Is that what you're going to ask me about?
No, I was just
You mean because, oh, yeah. Oh, yeah. Okay, right. You have two different equations and they equal two different answers. So is that something that can happen?
Apparently it is.
Yes
Yeah,
or
you
no?
have quadratics.
Well, let's look. So, okay. I'm 100% sure it's yes or no. So once you add straight down, what happens with your variables?
Go away.
Okay, so then what are you left with?
8 equals 4. Negative 8.
Let's try that again. So on this side you have what?
0.
On this side you have?
-4.
Okay, so it says 0 equals -4. Is that a true statement?
No.
No. So then what is this system?
Doesn't work.
It doesn't work, right? It's not a true equation, so there's no solution when we say that the system is inconsistent. Okay, so what Logan noticed is that didn't seem right. I can't have two of the same equations, but then they're equal to something different. So that would be an inconsistent system. Now, remember what I told you earlier. If you had something where 0 would equal 0, that would be a true statement. And we actually have a word for that. It's going to be dependent. Yes. Just like you on your parents' taxes. You are dependent. Shoot. Okay, so let me finish explaining this part then. All right, so once you get the 0 equals -4, that statement is not true. So because that's not true, there's no solution, and we call the system inconsistent. Now, sometimes you'll have a true statement. If the statement was true, there'd be an infinite amount of solutions, and we would call the system dependent. An example of a true statement, you'd most likely get 0 was equal to 0. Okay, yeah, Jonathan?
Would you be a good teacher not do this to us in our test?
What do you mean?
Don't do this to us in our test, please.
Well, it's very possible.
I don't think about the test, just don't make us do it on the homework.
Are we gonna do it on linear?
Oh, yes. Check it. Okay, so what you guys are going to do for homework is this. Now, with your last section, you're not going to do a homework log. I'm just going to be checking in your homework. So,
For correctness, or just like to see if there's stuff there?
just to see if there's work. Well, it needs to be accurate. Okay, so you're doing 8, 13, 17 through 23 odd. So really, you can check those to make sure that you did get the correct solution. But all we did today is we used algebra to solve. So for full credit on your homework, you're going to have to show me how you solved. Okay, so and that's what I'll be checking tomorrow. Yep.